Newton's first law is a body will remain at rest and a body in motion will remain in motion unless acted upon by an external force. So for our car, whenever it's just sitting there before we release the tension, the car stays the same. But once the force from the fishing line is released, the car is able to move and accelerate. For Newton's second law, it is the force acting on an object is equal to the mass of that object times its acceleration. So the amount of force applied to the car is greater than the mass of the car. This allows for the mousetrap with the string to push the car. So if our car weighed more and the force from the string wasn't as strong, the car wouldn't move. But since there's more force acting upon it than its mass, the car is able to move. Newton's third law is for every action, there's an equal and opposite reaction. Now, this can be seen in a various amount of ways. For example, the way that we wind up the fishing line in the opposite direction and it propels in the other. So like we wind the fishing line back, but the car moves forward. Or whenever we release the car and it hits a wall and it bounces back, which you'll see in the video, that is Newton's third law. When using our car, we can see both potential and kinetic energy. So potential energy is energy stored in an object due to its position, and kinetic energy is energy that a moving object has. So whenever we wind up the string and set up our mousetrap, that is all potential energy. And then once we hit the mousetrap, this is all released and converted into kinetic energy. Hey. With our car, you can see an unbalanced force taking place. So there's 9.8 newtons of gravity acting upon it from top, if you can see on this diagram. And there's force from the back of the car and force acting from the front of the car. And there's also friction. So the amount of force that is propelling it from the string when it's released is greater than the force of gravity and the opposing force for when it's moving forward, which allows it to accelerate. With our car, we can see speed, velocity, and acceleration. Speed is a scalar quantity that refers to how fast an object is moving. On average, our car moved 0.95 meters per second. We also see velocity, which is the rate of which the position of an object changes. So whenever our car moved from one place to another, that is velocity. And then we have acceleration, which is the rate of change of velocity. So the acceleration of the car is the rate at which velocity is changed. When the mousetrap is released, the car accelerates forward in reaction to it. And our acceleration of our car on average was 0.119 meters per second squared. Friction is a force resisting to a relative motion of solid surface, fluid layers, or material elements sliding against each other. So with our car, to add friction, we added balloons around the wheels. The increase of friction allows for our car to move at further and faster speeds. We had a problem with the balloons though, that they were rubbing against our axles, and we found that it was adding too much friction. So to counteract this, we took off the balloons, and this decreased the amount of friction rubbing against our wheels, which allowed us to reach higher speeds. So once we took off the balloons, we were able to maximize the possible amount of distance we were able to get our car to go to.
Why are our wheels wobbling?